Alright guys, I've had a few requests from people who had old CPS 1.5 sets that had previously been um, revived through the old method, through the Dead Battery Society method, which was fine for its time. It kept a lot of these out of the dumpsters, but now we have better ways um, to use the original game code and still revive the game. So I've had requests from people who wanted to undo that process so that they could then do the newer methods. So I wanted to run through that with you. This is a USA Slam Masters, and this is actually Slam Masters is actually the worst case scenario because it actually had additional circuitry not required by the other games like Punisher, Warriors of Fate, Cadillacs and Dinosaurs. They didn't actually require as much modification as this one did. So as I go through this removal process, restoration process, I'll point out to you what things are common to all of the CPS 1.5 and what things are particular to this one. But I wanted to do this one because it's the worst case, so you can see how involved it may be for you. So first thing is to open this up. I've already removed the screws. The front of this can have up to 7 of these Torx screws. It's a T10 Torx screw, and it uses these specialized security bits. And then on the top, there's usually little plastic plugs that are either glued in here or taped in here. I've seen it different ways. And inside of that is a just a regular Phillips head screw. It's kind of got a little flange on there. So you take those out. And then there's also clips that run along the inside, both the sides and the back. And so this is still held on to some degree. So I'm going to push down and push up like that, and it pops up. This came out pretty easily because I've opened it before. Sometimes they're a bit stubborn, but if you use opposing pressure, it should come off. These are still attached because of the fan cable. So in order to remove that, you push inward towards this capacitor and then lift up. So I'm pushing in and then I'm pulling it up, and that just comes right off. There's a little flange here that holds it to that connector. So I'm going to move this out of the way. And then what we want to do first is look at the chips that have been, the code has been changed in. I have verified this works. That's step number one, is if you buy one of these used, make sure that it works as is before you start monkeying around inside, because you don't want to have compounding problems that are very difficult to trace back to where it started. So start out making sure it works. If it works, good. Pop it open and then start looking at what's inside. So this is ROM 23 here on the B board, and we're going to need to reprogram that guy. If you look on here, it says MBU. That's Muscle Bomber USA. Muscle Bomber was the Japanese name. This is a Slam Masters, but the U makes it USA. And so that's important because we're going to need to look at the files from MAME. You're going to have to download the file set from MAME to get the original files for these chips, and MBU is important for that reason. So we'll look at those files in a moment here. So that's that chip on the ROM board. Then we're going to look at the Q-Sound board as well. And this one, all of these Q-Sound mask ROMs, those are fine. It's just the program that's been excuse me. Okay. Just the program that's been modified here. And depending on the game, this is going to be a different size chip. So on Muscle Bomber, this is a 4 megabit EPROM, and on the other games they use a 2 megabit EPROM, and then on an unmodified game it's a 1 megabit EPROM. So I will show you how to use any of those, because you can use any one of those chips provided you set up the file appropriately. So I'll show you how to do that. We're going to put this down and take this over to the computer, and we'll look at how to deal with these files. I wanted to discuss again real quick those different sized chips. So these are all 32 pin EPROMs, and they are JEDEC. There's JEDEC and non-JEDEC. These are JEDEC. And what that means is that they all adhere to this same pin order. And depending on which chip it is, it may or may not use all of these address lines. So for a 1 megabit, it's not going to use address lines 17, 18, or 19. For 2 megabit, it's going to use 17. For 4 megabit, it's going to use 18. And for 8 megabit, it's going to use 19. And if you look at the layout on the on the bottom side of this this chip right here, all of these signals right here are tied to 5 volts. So that means the highest megabit of any of these chips that are plugged in is going to be addressed. So you need to make sure that if you're using something other than a 1 megabit chip, that you stick your program in the highest megabit of that chip. And I'll show you how to do that. We'll start out with the most straightforward one, which is a 1 megabit chip. That would be ideal because you don't have to change the file at all. This is a BP Microsystems 1200, and I've got a bunch of different programmers. I'd like to do a separate video on EPROM programmers in general, because they're kind of fun, and I've got a few different ones to show off. So I've downloaded a variety of CPS1.5 ROMs from the interwebs. If you're not familiar with how these files are organized, they are organized with a master or a parent, which will be a large file compared to the region-specific files. So this is slammast, and that's the 6 megabyte file. And then the USA-specific one is slammast U. And we need to pull. I showed you those 2 chips that have been modified. We need to pull a file out of each of these for our purposes. This is the QSound program, this MBQA. So we're going to copy that, and we'll just dump it out in this directory. And then we need to grab that 23 file, EPROM 23. And again, like I was saying, that was important, that MBU. There it is, MBU 23. You can grab that, and we'll dump that out here as well. Okay, so we got our 2 files that we need. And you'll notice here, this is the QSound program. So that's 128 KB. If you wanted to translate that to megabits, you go times 8 to turn it into bits. And that's roughly 1 megabit. So that's where our 1 megabit file comes from. And then this one down here is 512 KB times 8 makes it roughly a 4 megabit file. But this is a 40 pin chip. So we actually use a larger physical size chip for that. So let's go to our programming software. And every programmer is going to have an interesting and unique interface. Some of them are easier to understand than others, but this one's not too bad. So let's choose our device. I've already got the ST Micro Electronics list queued up here. But you can sort, usually these software packages, they'll allow you to sort by stuff like this, like physical package. Ours is a DIP. Ours is an EPROM. So that helps you narrow down your list a little bit. So I want to do the 1 megabit chip. So go here and we'll select that. And then they don't call the file a file, they call it a data pattern, which is kind of interesting. So we're going to open our file here, and browse for it, and we'll grab our QSound file. Open that. We'll say OK. And you'll see right here it says the size in hex is 20,000. And up here, the chip we've selected is also 20,000. So we know it's a direct match size-wise. And we'll say OK. And that's all loaded up. And we'll go to our Program tab. So what this is going to do is it's going to check to make sure all the pins are connected. That's continuity. It's going to check the ID of the chip because the chip actually has an embedded ID, and it'll verify that you've stuck the right chip in there. It'll make sure it's blank, program it, and then verify it. So we'll go, yes, we want to program the part. And this one's relatively quick because it's only a 1 megabit chip. The other chips take longer, as you would expect, because there's more memory to program and verify. So I think I have in my device programmer collection probably maybe half a dozen different programmers. So I look forward to doing a video on the different ones. So that guy's done. That's our 1 megabit chip. Now let's say that we've got one of the games that has a 2 megabit chip. Well, let's put one of those in there. And we'll have to go up here and we'll change our device to the 2 megabit variant. We'll select that. And we're going to look at our data pattern here. And we're going to go to Edit. So we've already got the same file queued up. It's still the same size, but we're going to need to edit this because if you look at the size up here, it's twice as big. It's 40,000 hex instead of 20,000 hex. So we're going to go in here. This is the actual game code or the QSound code inside that file, and we're going to copy. And our start location that we want to copy from is 0. And then we're going to want to go right up just below 20,000 hex. So it's going to be 1, 2, 3, 4. So that's the last memory address before you get to 20,000 hex. And we're going to stick this at 20,000 hex. And we're just going to say OK. And you can see that our address jumped to the very end of that buffer. So here's the data. And this is just an exact copy of the first megabit copied to the last megabit of that chip. And we're going to say close. And now you can see that our buffer has doubled in size because we edited our file to match that one. We're going to say OK. And we're going to go for it. Yes, we do. I know if you look back in the day on the sales bullet points for the flyers on these programmers, sometimes they will boast about their programming speed, but I think that's really only relevant if you're programming, like hundreds or thousands of chips. When you're doing one-offs like this on an arcade board, it really isn't a big deal. But it's kind of funny looking through those old sales sheets to see how they tried to convince people to buy their programmer versus somebody else's. So this is our 2 megabit chip. And that is completed. So as I was saying, the games other than Slam Masters would have that 2 megabit chip installed. So Slam Masters has a 4 megabit chip installed. Pop that in. And here's what we'll do. We will we'll go to our data pattern again. And, oh, I'm sorry. We should change our chip here. Let's cancel out of here. Let's change our device. Go to the 4 megabit variant. Now we'll change our data pattern. See, it's still the smaller buffer size. Our chip goes up to 80 80,000 hex. So let's go edit this guy, and we will do the same thing we did before. We're going to copy our lowest megabit into the highest megabit. So on this chip, that's going to start, the highest megabit is going to start at 60,000. So we'll copy that in, and you can see that we jumped to the very end there. We have in fact copied that data. We'll close this, and we will say OK to that, and we'll program it. Yes, we do. And as you would figure, this is going to take roughly 4 times as long to program as the 1 megabit chip. And I'll go ahead and use this 4 megabit chip in our installation so that it's close to what you would expect. Because some people don't actually have lots of spare EPROMs floating around. So the most straightforward thing would be to erase the chip that came in there. It doesn't have the original label on it anyways, so who cares? So the most straightforward would be to erase that guy, reprogram it with this modified file, and call it a day. So let's check this guy out. Yeah, the Dead Battery Society mod is actually pretty ingenious. Kudos to whoever came up with that. That's pretty great. So it definitely served its purpose for those years. And this just needs to verify. This is if you're curious, this is an XP computer. And the reason I'm running XP is because pretty much all the software I'm running on it is from that era. So there's really no reason to run anything more modern. This is a parallel port programmer. It's not even USB. And works great. So here's our 4 megabit chip. I'm going to throw a sticker on there. And now we're going to program that 23 EPROM. So stick this guy in here. And depending on the programmer you use, it may want the chip shifted all the way up or shifted all the way down. So that's something to pay attention to if you're new to whatever programmer you're using. So we're going to change our device to, it's another 4 megabit chip, but as you can see, it has a lot more pins than the other one. So this uses, in the case of ST Micro, it uses this 402 variant for that. So select here, I'm going to choose a new file. I'm going to go browse for that other one, the MBU23. And we're going to say OK. OK. Alright, and one thing that you may notice is this says 40,000 and this says 80,000, and you might think, oh no, the size is different. Well, this is 80,000 hex bytes. This is 40,000 hex words. That's a 10 hex. So this is times 16, this is times 8. So that's the explanation for that discrepancy. It'll be fine. So let's program this guy. And we're going to say, okay. And this will take some time. While we're waiting for that, I'll talk about this a little bit. So you see these wires hanging out here? That is unique to Slam Masters. That won't be the case for the other games. And we're going to, might as well take this off. So we're going to take off this faceplate, and I'm just pulling towards myself. And eventually this will come off. Okay, so there's that. So inside of here is going to be a interesting mess. Basically, the mod involves adding in a logic chip that will help to switch between address lines in the QSound EPROM. And there's really no I don't know, totally clean way of doing it. So depending on who did the mod, it may or may not be interesting. So these are wired together. I'm going to carefully flop this over. Looks like they covered their little circuit with some electrical tape. So all of this wiring and that extra circuit will come out, and we'll do that here in a moment. Looks like our chip is done, so we'll pull this guy out and put him with our other one, and I'll grab another sticker for him to protect his little window. Okay, so our chips are prepared, and I guess we can dive into removing this extra circuit that's here. Let me put the camera up here and adjust this a little bit, and we'll zoom in some. Alright, so I'm going to try and be careful not to yank any wires off. So there's a few contact points here. Let's see if that's close enough. I might zoom in a little bit more. Sorry, just trying to adjust things for a better view. Yeah, that's decent. So get some tweezers, and first we'll take off this wire. I'm just going to heat that up. That came right off, that's great. Dig in here, grab this other wire. That guy came off easily. And we'll try and get this guy. Okay, that guy came off. So when you take these wires off, just make sure that there's not little bits of solder connecting two pins. That's the main thing to watch out for. Okay. This guy out. And this guy. Okay. Alright, that looks like we got all that. I don't see any bits of solder connecting two pins. You could come back through here and clean up the pins some more to get rid of the flux and make it look shiny, but this is fine for now. I'm just removing the tape here. Nothing else is connected electrically on the bottom board. And then we can remove it from the top board. So let me get this board into position. Here. Yeah. Okay, that's good. So, this area right here is, this is where I spoke earlier about those address lines on the original board all being tied to 5 volts. So in order to do this mod, those pins were separated. The traces between them were cut. And so we need to rejoin those. I'm just removing these wires before we do that. Okay, so those are out of the way. And then all I'm going to do now is I'm just going to get a big solder blob going between these last 3 pins here. You could use a piece of wire, but I think a solder blob will do. So all those are connected. Should be good there. And go ahead and remove this. This is the backside of the kabuki chip. No traces should have been cut here. If you see more than the wire that jumps from here to here, and then the 2 wires that jump from here to that other board, somebody may have done a repair. So it's good practice that before you start undoing things, to take a photo of it, so that if you need to backtrack, you know where you came from. So that looks good here. I don't see any broken traces. And then we still have a couple wires on the top side of this board to remove. And sorry for the angle, it's kind of goofy, but I just want to get this in frame. And wire here. Okay, there we go. And then another wire over here. And again, you just want to make sure there's no solder bridges between any of those neighboring pins. So that's our little logical mess there. Get that out. And now we can start restoring some other things. So we've already fixed that solder blob here, that guy. One of the other modifications was that there were, let me see if I can change this a little bit better. Alright, so one of the modifications that was done was this capacitor was replaced with a solder blob, and this resistor, it's hard to see, but there's R33 right here, was just removed entirely. And so what that did was it the signal, you can see this big trace here, that was normally powered by the battery circuit, and this modification connected that power line, or that signal, to ground, which effectively turns this this custom Z80 into a regular Z80. And so we need to restore that. And the resistor value was originally a 1K resistor. I'm sorry, not a 1K, a 1 ohm resistor, so pretty low, but it's such a low current signal. It's pretty flexible as far as what value resistor you could use. I mean, you could get away with a 10K if you wanted to. I've got a 5 ohm. It's just something I had handy. So I'm going to put a 5 ohm here. And then the capacitor, if you wanted to be really lazy, the capacitor isn't even absolutely necessary, but for the sake of thoroughness, we'll go ahead and put that there. That's a 0.1 microfarad capacitor. So I'm going to try and get in here with my iron. I've got too many wires and cameras going on here. So we're gonna solder one side of this, get him stuck in there. And then solder one side of this guy. And we're going to solder the other side. Sorry, I'm trying to not block the camera. Whatever solder the previous person used was pretty gross. Okay. Not the cleanest. I'll probably go back through with some alcohol afterwards to clean that up. There's one last step for soldering, and that is going to be on the C-board. So let's clear out some space here, and we will check that out. So we're gonna remove the C-board from that, and we're gonna have a look-see on the bottom side. So the modification that was done here was to lift, well, so some people will cut these little traces here, and some people will lift these pins. I find lifting pins a bit risky, so I wouldn't have done that personally. So there's multiple ways you could go about it. You could remove this wire and then stick those pins back down and solder them down. The risk being that these pins are so close together, you might accidentally bridge with solder to one of these neighboring pins and just make a mess of it. Since these are already lifted and already connected together, I think the simplest thing would be to leave that wire there and just move where it's connected. So right now it's connected to 5 volts, or at least the battery circuit. And so what we want to do is move this to ground like it was originally. You can see these traces here were originally connected to ground. So if you follow this copper, see this is ground, 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 and you can see over here that this is still ground. So if we just move this wire from here to here, that should do the trick. So I'm going to put this down here, and I might rotate this a little bit to make it easier to do the soldering and the camera. So let me grab this wire and I'll come in here, get that guy melting. Okay, that looks good. And then I'm going to put a little blob of solder on this resistor that we want to solder to, just to make it easier. And then I'm going to grab this wire and we're going to solder that to that point, and that should do the trick. So sometimes rather than make it perfectly original, the risk is greater than the reward. So in this case, I'm just going to leave it be. I'm not going to try and lay those pins down and mess with that. So let's put that back on here. Zoom out a bit. And in this case, I'm also going to be using an Infinikey. So let's go ahead and install that while we're at it. This is a muscle bomber. So we've got a 1 here and a 1 here. All right. So we're going to mate these guys. Make sure everything's lined up. And you can see the keys are on the same side. Key, key. You don't want to get those backwards. Mash all this sandwich down. We got our key here. So that means it needs to go this way. And we'll get this guy in here. These can be a bit of a tight fit, but just apply some controlled pressure, get them to sit down. Looks like we got some on this inside edge just to go down. Okay. All right, so that is all in place, and we can swap out this chip now. Our 23 EPROM, and put this guy in. And before you put these in, you want to make sure that the pins are nice and straight, because if you don't check, you might find out later that there was a pin that was flopped over or something like that. Okay, so this board's done, this board's done. Let's grab this board and we will swap out that other chip. Our Q-Sound program. Okay, put this guy in. This guy, his legs are flared out quite a bit, so he's kind of difficult to get in, but we got it. And we're also going to put in a Kabuki Infinikey on this guy to revive him. So let's go ahead and grab one of those, this guy, and he's going to use the same code as the other one, the 10001 for Muscle Bomber. So put that in, and put him in. We'll put this guy in. Okay. We'll mash this together good. Okay. Alright, and now I'm going to bring the camera back all the way up. Again, excuse my horrible camera skills. Alright, that should be good. Get some of this cleared out. Alright, so I start putting everything back together. So this we need to make sure is plugged in well. And then we've got these two boards. I'm going to make sure those are plugged in well. And then in order to test, we should put our faceplate back on. And I think I mentioned in my other CPS 1.5 video, these pins are pretty nasty, so be careful when you're pushing this in that you don't really stab yourself good. Okay, so I don't have a video switcher, so pardon me a moment. I'm going to connect up my PC monitor to my JAMA setup real quick. Alright, video's hooked up. Let's get our JAMA connector in here. And alright, zoom out. Moment of truth. Got some audio. There we go. And video. Alright. Slam Masters. Alright. Alright. There it is. It is working. So, sorry for the long video, but I don't know how much shorter I could have made it with the amount of information that needed to be in there. But yeah, hopefully that helps you out. And if you have any problems, feel free to put questions down in the comments below. I'll try and put into the video description more information about the EPROMs, because there are different manufacturers and different part numbers for the same size EPROMs, and I know that can get awfully confusing, so I'll try and put in some of that extra information in there to hopefully make it easier on you. And again, I also wanted to make a separate video on device programmers in general, so maybe that will also help answer some questions for you guys.